Today we are going to discuss about the addressing modes in 8051. It is nothing but the method of accessing the data which is to be incorporated by the instruction. It could be able to access through by means of CPU or by using microcontroller to access the data. But whatever may be the mode of operation, if it is a process of specifying the data by the operand of the instruction, then we termed it as the addressing mode, and which indirectly give the mode of program for the increasing speed of the CPU as well as the processing time can be shortened. There are 5 types of addressing modes are available in 8051: register addressing mode, direct addressing mode, register indirect addressing mode, immediate addressing mode, and indexed addressing mode. This is a nutshell of all the 5 addressing modes in detail with a simple examples. Let us go by one in detail. Register addressing mode. So when we say register addressing mode, the register will be specified in the instruction. This instruction is used to involve the transformation of information between the registers. One will be your accumulator, the other will be a default registers that are available in 8051. It could be A register or B register or the registers ranging from R0 to R7. Okay. For example, move A, R0. What does it mean? The content of R0 will move to an accumulator. And there is an invalid instruction is there that one of such operand must be an accumulator. Register addressing mode. This is an example. Further enhancement if add A, R7. Here R7 is a register, accumulator is also a register. Or it could be an immediate data which is moving to a register R0. So these are all valid instructions of register addressing mode. When I say direct addressing mode, the address will be directly specified in the instruction. An 8-bit address will be directly specified. So the pointer will go to the corresponding address specified in the instruction, take the data and load it in the destination point. So in this example, move R0, 40H. What does it mean? It goes to the 40th memory location. For example, it takes the data called 05 and put it into the register name called R0. So now the value of R0 register will be equal to 05 after executing this instruction. Similarly, when I say another example with the move 40H, A, the content of accumulator is moved to the address location 40H. So valid memory address for direct addressing modes. So we cannot use all the addresses, and we know that there are byte addressable and there are bit addressable and there are general purpose addressable registers we have. And which of those can be used? There are 128 locations are used for special function registers. Can we use that? Yes, you can use it. Because we know the port 1 is for 80, port P1 for 90, AH, A0, B0, D0, and program status. These are all special function registers. Correspondingly, it will have their corresponding address. Those addresses can be used for special function register. Registered indirect addressing mode. Here address will not be directly specified, whereas the address will be indirectly specified by the pointer registers, namely R0 or 1 for 8-bit and the DPTR for 16-bit content. DPTR is used for accessible the operands which are in the external memory, of course. Example: move at R0, A. What does it mean? It tries to take the data from accumulator and goes to the location where the register R0 is pointing out. For example, if R0 is denoted by a value called 50, it goes to the 50th memory location and copies the content of the accumulator into that location. That is what the meaning of this instruction. A, address of DPTR. If a DPTR is initialized by the value of 1, 2, 3, 4, the representation of the address represents the 1, 2, 3, 4. The DPTR value is now acting as an address. It goes to the corresponding location in the stack, take the data from the location 1, 2, 3, 4 and copy the data into accumulator. And these are further examples which will enrich the content of addressing mode. Indirect addressing mode, the similar locations. That's what we conveyed here with respect to A, address of R0 and A, address of DPTR. The fourth addressing mode is the immediate addressing mode. What does it mean? The immediate data will be directly specified in the instruction with the symbol called hash, followed by an 8-bit data, and that will be transferred back to the destination, and it could be an address, it could be a direct data, or it could be an indirect data. Example: A0H. So A0H is an immediate data because it is having a symbol called hash that will move to the accumulator content after execution of this instruction. Indexed addressing mode. So when I say index addressing mode, it is an on-chip ROM access and it will not retrieve the data from the lookup table. That is one speciality of this kind of addressing mode. Okay, the sum of these two registers will affect the address from jump or move instructions. So typically we will be move with a DPTR register whenever we are using this index addressing mode. The only one instruction used for this index addressing mode is move C, A, at of A plus DPTR. So A value will be having some value, DPTR is having some offset value. You add both the values together and go to that corresponding location in the stack, take the data and load it into a particular register called accumulator. C represents here this code. With the index addressing mode. Punch program started with the origin ORG00H. DPTR is loaded with the register 300, accumulated with the immediate data. So that data is going to P1. So now P1 is moved to A. So what is the A value? FF. Now that will be added with the DPTR. So now that will become 3FF. Am I right? That goes to the location and takes the data and put it into accumulator. And this is what is going to happen in this particular analysis. register specific addressing mode inherent in the instructions, and these instructions will normally specify the register such as accumulator or a DPTR. A good example is swap A. He tried to swap the content of the accumulator, the lower order nibble with higher order nibble. For example, if we have the accumulator registers 49, at the end of this instruction we will having a value for 94. Then another is a stack addressing mode. It is a subset of direct addressing mode where the address is directly specified, but it uses the operation of stack with the help of the instructions push and pop for entering as well as retrieving the data to and fro from the stack. Push 04. The content of R4 is pushed onto the stack. The content of R6 is moved to the stack when we use the instruction push 0h. So these are all the varieties of the addressing